Once you open the alignment software, you'll see a list of 7 steps to be completed on the left. You'll want to start by selecting the first image in the sequence that you want to align. Next, you can scroll through all the images in the sequence using the selector in the bottom left. Notice how all the images are quite dark and each frame has a varying brightness level. To fix this, move on to the contrast adjustment step, where the software will perform an automatic adjustment on each frame to improve the visibility and keep everything at a consistent brightness. Next, the user may want to perform some bulk adjustments on the image sequence, such as doing translations, scaling, rotation, or adjusting the image's resolution. This can all be done through the transformation window. After that, the software can proceed with its first alignment pass. This coarse alignment visually compares neighboring images and computes an XY shift for each image to try and minimize jarring frame-to-frame movements. Next, to further align the images, we must track the locations of particles across the image sequence. In the automatic tracking step, you can click on the image to indicate the initial locations of particles, and then click Track All Selected to allow the software to automatically determine the subsequent particle positions across all frames. Now, the automatic particle tracking is not perfect, and it sometimes fails. Especially when there are many particles which overlap, the software often doesn't know which particle to follow. As can be seen here with particle number 5, where the software gets confused and switches to tracking the wrong particle halfway through the sequence. To fix this, go to the last frame where the particle was tracked correctly and click Mark End. This will trim the bad particle data after that point. After that, advance to a frame where the particle is clearly visible again and no longer overlapping. Click it and track it once more to fill in the positions at the end of the sequence. Once that is done, there will still be this gap where the software doesn't know where the particle is. To patch this up, use the Interpolate Selected button to get the software to fill in the gaps between the known positions. Next, if automatic particle tracking isn't enough, you may want to optionally perform some manual tracking. In the manual tracking window, you can see 2 graphs, one for a particle's X position and one for the Y. You can use the buttons at the top to switch between which particle you are currently editing. Then, on any frame, you can click on the image to change the particle's position. You can also use the directional controls on the tracking window for finer manual control. Next, let's have a look at how you might track a particle entirely through manual tracking. To start, select a new particle. Next, we want to indicate its location to the software by clicking its position at regular intervals across the entire image sequence. Here, I selected a position every 5 frames or so, but other intervals work too. You can see the graphs populating with points as I indicate the positions on the images. When you're done selecting the points, click Interpolate, and the software will try to fill in the gaps. This process, again, is not perfect, but it gives you a good jumping off point for further manual tracking. Once you're done with tracking all your particles, it's time for the final optimization step. As you can see, we're back to our original unaligned images. To configure our optimization, we need to tell the software how much the object in the image is rotating by. In our case, the object in the image is rotating by approximately 3 degrees in each frame, so the defaults here are good. You can also optionally specify tilt angles via a CSV file, but we won't be doing that for this example. Next, we need to tell the optimization step which variables it's allowed to adjust. For this example, we'll give it the most control possible by allowing it to have a separate rotation and magnification variable for each frame, as well as to allow it to adjust the azimuth angle and to adjust the tilt angles after the fact. Now, the final alignment pass will run using all the tracking data and settings that we have provided, and an optimized aligned sequence of images will be output.